Hello everyone, I'm trying to welcome you to today's class. I'm going to Chukwu promise. Over the years, I've helped students move from confusion to clarity. Growing up in a family of teachers, I've learned that education is more of acquiring good results, but shaping minds and building confidence. Being able to defend that good results anywhere you find yourself, that is the experience I want you to have in this tutorial. And today we'll be diving into an interesting topic on chemistry. Let's begin with introduction to chemistry part 2. We have done part 1 when we discuss about the origin of chemistry. Now let's look at chemistry in details. Okay, what is chemistry? Chemistry is the study of matter, its composition, structure, property, and changes that occur during reaction. Okay, from our definition, we are studying chemistry is all about matter. So let's look at matter. What is matter? Matter is anything that has mass and occupies space or volume. Let's look at matter in particular. Matter can be categorized into three forms. Number one, based on physical properties. Number two, based on room temperature. Number three, based on natural occurrence. Based on physical properties that are grouped into three: metals, non-metals, semi-metals, and metalloids. When you talk of metal, they are shiny or lustrous what material. They are good conductors of heat and electricity. They are durable. They are malleable. What I mean by malleable, they have the ability to be hammered into what thin sheet. When you place it there, they turn to what a thin sheet. They are ductile in the same thing that they can be drawn into what wires. This is what malleable and ductile. This is when you hammer it, it turns to what they become into what a thin sheet. And these ones they can be drawn into what wire. They wires. They can be drawn into what wires. Okay. Example of this matter, we have something as copper. We have something like silver. So this copper, for instance now, silver is the highest heat conductor, known. But due to the silver is very costly and expensive and it's rarely seen. So that's why the most of the wires we have in the country or that most of the wires we have are made up of what copper instead of what silver. Okay. Another one is non-metals. Non-metals, they are opposite of what? Metals. They are dull. They are poor conductors of what? Electricity. Okay. They are braced to when solid. Okay. Example of this non-metal, we have something like oxygen. They are what? Non-metal. Okay. Then let's look at what? Semi-metal or metalloids. We have metals, non-metals, metalloids, or semi-metals. This thing, they have the properties of both metal and non-metal. They have the properties of both metal and non-metal. Let's look at matter that occur in nature. We have two. We have one that occur in occurrence based on occurrence. We have one that occur in nature, which is what oxygen. Oxygen occur in nature. Then we have another one, good, occur in nature. Then we have someone that is artificially made, that made in laboratories. We have technutum, technutum, and in in esteeming than maybe want in laboratory. Matter exists in different categories. Matter exists in room temperature, it exists in natural occurrence, and it exists in physical properties. But let's go over to matter existing in natural occurrence. Matter exists in solid form, matter exists in liquid form, matter exists in gaseous form. Then when matter exists in liquid form, we are looking at liquid like matter being in mercury. In a solid form, matter exists as what? As iron, stone, or ice block. Okay? When matter exists in gaseous form, we are looking at matter as iodine or naphthalene or even camphor. Okay? When camphor is being sublimed, we say that camphor is a matter in gaseous state. Okay? But mind you, matter exists in three main forms. That being written it. Okay, when we look at matter existing in room temperature, you have matter in solid, liquid, and gaseous. They are the same thing. Okay. Then some matters have different temperature that exist. Some doesn't cross 50 degrees centigrade, depending on type of what room temperature. But specifically, when matter exists in natural occurrence, they exist under three things, which is element, compound, and mixture. Okay, but at the course of this study, at the course of this our topic, we'll be looking at them one after the other. Okay, then let me remind you, note that whenever we are talking matter, matter exists in three main forms, which is liquid, gaseous, and solid. Okay, we have mentioned it in these categories we have mentioned. Then when we talk about in liquid form, the state of matter in solid form, we are looking at example as ice or iron. Then the shape is fixed. They have a fixed shape. Okay, when you talk of volume, they have a they they have a fixed but volume. The volume is fixed in the sense that the height of the eyes, the height of the volume of the iron. Okay, then when we talk about the compressibility or the compressibility of the state of matter we are looking at, we say that the compressibility is very low. It cannot be compressed. For example, if you bring something like stone or ice, can you compress it? It cannot be compressed. We say that the compressivity is very low. Okay, example of this matter in solid form, I've said it before, is ice and iron. Okay, let's look at example of matter in liquid form. Example, we are looking at water and oil. Okay, let's look at the shape. The shape is not fixed. Remember, when you pour a liquid in a container, they assume the shape of the container. So the amount of liquid you pour, the amount of matter which is in liquid form you pour in a container determine the shape of liquid, the shape of container give the matter its shape. So the shape is not what? It's not fixed. Okay, what about the volume? The volume is also not fixed because they assume the volume of the container. If you bring 1 liter container, the amount of matter you pour in that container will be the equivalent of the what? Of the volume of that same container. what of the compressibility? I mean the compressibility of the liquid matter is very low. It's not very low, but it's what? Low. So that it cannot be compressed. Okay? Let's look at the matter in gaseous form. Example of this matter in gaseous form, we are looking at something like air. Okay? So let's the shape is not fixed. The shape is not what? Fixed. Because when you bring a balloon and trying to transfer air or to try to transfer air into such balloon or tube, you find out that the volume, they assume the volume of what? The container. So what about the shape is not fixed, the volume is not also fixed. Okay, but the compressity, it can be what? Compressed. The compressibility can be what? Compressed. You say that the amount of air that you pump into a tube, it can have no what? Have no scale. That's my that's what happen when you want to pump in air inside the tube. You may notice that they have a gauge they use to gauge it, but the highest thing that will occur is that the tube will what? Will burst. When the material contain more of what the material expected to contain, the material will burst. The same thing is applicable with what? Balloon. When you get a balloon and you want to put in air which is more higher than the volume the balloon will contain, at a point the balloon will what? Burst. So the complexity is high, can be compressed. Okay? Okay, let's go on. Let's look at the branches of chemistry. Let's look at the branches of chemistry. We have branches of chemistry. Okay, we have organic chemistry. Organic chemistry. We have inorganic chemistry. We have physical chemistry. We have biochemistry. We have industrial chemistry. Industrial chemistry. We have, let's look at this, but there are more of, we have more of this, but let's look at this thing in the meantime. Organic chemistry. Organic chemistry is the chemistry of carbon hydrogen bond. It's chemistry of what? Carbon hydrogen bond. In the sense that it's a chemistry of life. Example of organic chemistry, we have methane, we have ethanol, we have protein, we have carbohydrates, we have fat. They are what? Chemistry of what? Life. Because life have what? Carbon bond. Okay. Then we have inorganic chemistry. Inorganic chemistry is a chemistry that doesn't have carbon bond. That doesn't contain what? Carbon. Except element like or compound like uh, carbon 4 oxide and carbon 2 oxide. So this compound or this element I call now, they are inorganic chemistry. Okay, they are inorganic chemistry. That is CO2 and CO. They are what? Inorganic chemistry. Example of inorganic chemistry, we have chemistry, the chemistry of earth and its materials. Chemistry of earth and its materials. Example, we have acid, nucleic acid, okay? Acid, we have base, okay? They are all what? Chemistry of metal, materials, sorry. We have also metals here, okay? Then physical chemistry. Physical chemistry is a chemistry that tends to study the behavior of the properties and behavior of matter using physics and what? Mathematics. Using physics and what? Mathematics. They tend to study how. They tend to study what? The how. What is inside what? The component. The how and how much is what in the chemical what component. Okay, then we have biochemistry. This chemistry, physical chemistry have, sorry, before we go to biochemistry, physical chemistry have relationship with physics and what? Mathematics, physics and chemistry. I told you that this we have pure sciences. The pure sciences we have are biology, chemistry, and physics, and three of them what interrelated. So this is a relationship physics have with what? Chemistry. They study about here. They study about matter and energy. They study about what? Matter and energy using physics and what? Mathematics. Here we will study about the energy change. Okay, so let's go to biochemistry. Biochemistry is the study of living organism. Is the chemistry that study the living organism and the components of living organism. What are the chemical components in living organism? Here we study about enzymes, hormones, photosynthesis and respiration. What are the chemistry that the chemical reaction, I mean, that occur in living organisms is what we study here. What was industrial chemistry? Industrial chemistry is the chemistry of production, turning raw material into useful products. They tend to study how the large scale production can be done. Okay, then we have another one which we call analytical chemistry. Analytical chemistry, in this type of chemistry, they study the identification and measuring of chemical components. They identify and measure the chemical what component. What they analyze, how much how much is in that chemical what component. In this analysis they do what is we call what qualitative analysis and quantitative analysis. How this chemical component, or how this chemical component is, then that is qualitative. Then quantitative, how much is involved in this chemical component. Okay, then we have another one, theoretical chemistry. You can do that research on your own. We have a theoretical chemistry. They use mathematics and simulation in solving chemical processes. Okay, then and so forth and so on. Then we have the usefulness of chemistry. The usefulness of chemistry. Chemistry has done more to human beings because in medical the knowledge of chemistry have helped us to produce some vaccine and drugs used in prevention of and taking care of the body. They use in prevention of diseases and also to take care of our body. That's done with the application of what? Chemistry. Then the production of fertilizer, pesticides, insecticides, herbicides are done with knowledge of chemistry. Okay, when it comes to food preservation, some chemical products have been produced with the knowledge of chemistry to preserve what? Food. For instance, there are times when beans are not preserved longer, but due to the knowledge of chemistry, some farm produce are preserved for future use with the knowledge of chemistry. Okay, what of in the industrial aspect? Chemistry have help us to produce the raw material, to transform raw material to useful product. That is the usefulness of what? Chemistry. Then what on in terms of environmental management? The use of chemistry have helped us to manage some environmental hazard like pollution. So we it tends to, for now, the ozone layer, so we tend to know what we can do to prevent what? Ozone layer, and where to light up our what? Waste products. You know, lighting up your waste products in a public place can cause what? Environmental pollution or environmental hazard. So knowing the type of area or type of places to discharge your chemical products or your chemical waste help us to avert and reduce what? Pollution, environmental pollution. Okay, so let's dive in to the matter in natural occurrence, which is what? Element. What is element? The element. What is element? Element, they are the type of, they have one type of what? Atom. Element are substance which cannot be simplified by ordinary chemical process. They cannot be simplified in ordinary chemical, by ordinary what? Chemical process. Okay, so we have element like oxygen, oxygen, oxygen. We have element like hydrogen. We have element like we have element like neon, helium, and so forth and so on. We have about 109 elements recognized what? Globally, but 98 of them occurred in nature. Okay, and this, do we have something? This thing, these elements are represented alphabet known as what? Chemical symbols. Okay, we have, for example, oxygen is represented with alphabet O. This alphabet O is known as what? Chemical symbols. We have hydrogen is represented with letter H. We have neon represented with what? Ne. Helium represented with what? He. So these alpha chemical symbols are got from two places. Number one, they are got by what? Their English name, like oxygen, the first letter of the English name, which is O. Then the hydrogen is also got from English name, which is hydrogen, for the first letter, which is H. There are some are gotten from the combination of the first letter and the other letter, which is in what? In cap, in small letter, which is, so example of, or new is gotten from the first letter and what? The next letter, but some of them might not be the next letter. Some of them might be the other letter that come after the first capital letter. Like magnesium. Magnesium, you have Ma and gotten, that started after magnesium, you have magnesium. This is the correct spelling. But we found out that this A is neglected. Then the symbol, the chemical symbol of magnesium is Mg. So sometimes they are not gotten the chemical signals are not gotten from the first letter and the next letter that come after the first letter. Some are gotten from elsewhere. Okay, like in case of magnesium, while some are gotten from Latin language. Okay, like silver, you have silver, which is what Ag. This Ag is gotten from the Latin name of silver, which is what and angetu. Angetu. This is where the Latin word, the chemical symbol is gotten. We have iron. The iron, which is what Fe. The Fe is the Latin name of iron, which is what ferrum. Okay, there are many of them. We have sodium, which is what Na, and this sodium in English word is spelled like this. Why is sodium Na? Is gotten from the Latin word of what natrium. Natrium. Okay, so this then this element give birth to what we call what compound. Compound, what is compound? Compound is the chemical combination of two or more elements. That compound is the combination of two or more elements that is chemical what combined together. Okay, for instance, we have compound like water, H2O. So this H2O, there are two elements, which is what hydrogen and what oxygen. These are two elements that make up of what water, which is what a compound. This is a compound. So is the combination is the when two or more elements combine chemical what combine together, they form what we call what compound. And from this compound we have what we call what equation. Chemical what equation. A chemical equation is the representation of elements to give a definite what explanation. To give a definite what explanation. Like when two moles of water react with oxygen, they give us what? They give us two moles of H2 H2O. So this is the chemical equation of water. They tend to help us to have a complex what analysis of how the compound is formed. We call it what chemical equation. Okay. Then let's go over to the next matter in natural occurrence, which is what mixture. One thing with the difference between mixture and compound, there are this one cannot be separated by what physical method, but mixture can be separated by what physical method. This one is combination of two elements, while mixture is combination of two substances. Are you getting me? Okay, when we talk of mixture, we have air as what mixture. Air contains hydrogen, oxygen, noble gas that are what the mixture that make up of air. Okay, we have something like a mixture like crude oil, we have petroleum, we have gasoline, that are mixture that come together that make up of crude oil. So the combination of two or more substances that can be separated by what physical method is what we call mixture. Okay, I've given an example of mixture, air, and crude oil. Okay, then let's look at atoms before we go over to separation techniques atoms and molecules, ions. Let's look at this this component of chemistry before we go back to separation technique. What is atom? Atom, they are simplest particle that take part in chemical reaction. They are simplest particle that can take part in chemical reaction. This atom is gotten from what? Elements. Okay. Example of atom we have hydrogen, we have neon, we have we have uh, we have nitrogen, which is represented with N. They are what? Atom, the smallest particle that take part in what? Chemical reaction. Okay? Is what we know as what? Atoms. What is molecules? Molecules molecules are a combination of two or more atoms that are what? Bonded together. Two or more atoms that are bonded together. We have what? H2O. We have O2, which is what? Oxygen. This thing represented oxygen plus oxygen will give us what? Will give us what? O2. Okay? So when two or more atoms are bonded together, they are referred as what? Molecules. Okay? That is, we have more of them. We have oxygen gas, we have nitrogen gas. Okay? They are what? Molecules. What is ion? Ions. Ions are elements that are what? That are they charge electrons. They are what? Charge electrons. Elements that are what? Charge. Okay. So when it comes in terms of these ions, they when the element tends to lose or gain electron to become what? Charge particles. For instance, now these ions, for instance, we have sodium. So sodium loses sodium. They lose one electron. They lose one electron. So when sodium lose one electron, they become what? Positively charged. Okay. When they lose one electron, they become what? Positively charged. Then we have there are many examples of ions. When it comes that, first of all, they are into two types. We have positive charge ions, which is what? Cations. We have negative charge ions, which is what? Anions. Cations and anions. So when this one loses an electron, they lose an electron. This one they gain an electron. And when this one loses an electron, it becomes what? Positively charged. When this one gain an electron, they become what? Negatively charged. So something like magnesium loses what? Two electrons to become what? A magnesium ion. This is what? Sodium ion. Sodium ion. Okay, you have magnesium. When they lose two electrons, they lose two electrons. Okay, we have aluminium that loses three electrons. Then another one, let's go to when they gain electron. That is what? Anion. Look at anions, which is the one that gain electrons. Example of this anion, we have fluoride ions, which gain one electron. it gain one electron to become fluoride ion. Then we have something like oxide ion. They also gain two electrons to become what? Oxide ion. Okay. These are these are the ions we have: anions and cation. Anion gain electron to gain negative charge. Uh, Cation lost an electron to become positively charged. Okay. Then let's go over to separation techniques. Okay. Separation techniques are the medium by which substances can be separated, by which a mixture can be separated to eat what? Various components. For example, let's look at various separation techniques, starting with filtration. Filtration, evaporation, decantation, sublimation, crystallization, distillation, fractional distillation, chromatography, chromatography, using a filter funnel, and so forth and so on. Let's start with filtration. Filtration occur when two or more substances involve two substances. When one when one have when one is very tiny than the other one is soluble in water and the other one is not soluble in water. The techniques used here, the apparatus used here rather, is filter paper. So this thing occur when you get your filter paper and you want to filter that substances. What is happening is that the one that is trapped in the filter paper is known as residue, while the other one is known as filtrate. So when you get that thing, like for instance, those people doing pap, you know that pap have a shaft, and they will also what? Pap. When you get your pap, you try to process your pap. Notice that the pap liquid will be soluble in water, while the shaft is not soluble in water. Then doing that thing, you notice that the pap that is soluble in water will pass through what? A sieve, which serve as what? A filter paper. Then when the sieve is passed by the on the through the when the solution, the pap solution which is soluble in water is passed from the sieve, which serve as a filter paper, and the shaft which is not soluble in water will be trapped by what? The sieve. That sieve, that shaft is what we call in chemistry as what? Residue. Then that part that is soluble in water is what we call what? Filtrate. And that give us the next one, which is what? Decantation. When you keep your pap for a longer time, you notice that the pap will sink inside the bottom of that container which you use to process it, and the water will what? Water which is what? Less denser. Remember, the pap is denser now. Because it's denser, they will sink inside the bottom of that container. Then the water which is less denser will what? Float on it. Then the decantation method is pouring out what? The water to have your pap. Okay. Then evaporation occur when two substances are at what? Boiling point. Have different what? Boiling point. Okay. So is involving volatility of that substance. Okay. Then when, for example, now if you spread your, or when you are cooking water, or when you are cooking something, you notice that at a point the water keep on what? Reducing in the pot in something you are cooking, or you notice that you are seeing something that is escaping from that pot. At a point the evaporation has what? Taken place. Another example is that when you expose the wet material under the heat of the sun, notice that at a point when you touch that material again, the water will not be here again. The water have been dried by what evaporation of the water to what thin air. That time the evaporation have what taking place. And another one is sublimation. Sublimation occur when the substances cannot be when the solid substances e pass directly to gas without what heating. Example of dis substances is camphor. When you get your camphor is a solid from different colours. Some are white, some are pink, some are blue, depending on the colour you buy. When you get them, at a point e starts smelling the having the smell of that cancer, perceiving the smell of that cancer. And when you start perceiving the smell of the cancer, we change not cancer, sorry, you start perceiving the smell of that camphor. And whenever you check the structure of that or the size of that camphor, you see that the camphor has been reducing in size. Okay, and that smell you are perceiving is what the gaseous camphor, that is what's coming out from that comfort, making that comfort to reduce in size. At that point, the sublimation has not occur because the comfort are passed from solid, which is the structure or the size of that comfort, towards the gas, which is the one it has smelling without what heating. Then another one is what crystallization. This crystallization occur when a material is what have a pure what crystals. When a material has what pure crystals. Example of this material is what um sulfur two oxide or sulfur two oxide. When this thing occur, the crystallization have taken place. Another one is distillation. Distillation is also related, has the relationship somehow related with what evaporation, but this one is involve what boiling point. Okay, when the boiling point, you know, the thing is when you get a substances and the thing you boil it, you put it under a temperature or a high temperature, and the material is what boiling. Notice that at a point some materials or some substances will be started what escaping through the thin air. At that point distillation has what occur. Okay, another one is fractional distillation. This fractional distillation occur when the substances have a close boiling point. They have what a close boiling point. Okay, it have relationship with what distillation. Okay, it have relationship with what distillation. Another one is chromatography. This chromatography, they are used in what hospital to separate what blood. They are used in hospital to separate blood. Okay, we have another one using of filter funnel. Okay, that one is also is a method used in separation techniques. Please subscribe. If you are watching this video on YouTube, please subscribe. Please help my ministry. My vision is to help many people succeed, especially young students. To be able to defend my knowledge, please help me. Subscribe. If you're watching it in another platform, please like, share, and comment. Let this video go viral. Let people know about this thing. Let them succeed in their academic work. Let them defend their knowledge. I beg, I beg. I'm begging. Many works are put in place for this video to come out. Please help me, help my ministry. I beg, please. We know that is watching